The field of data and computer communications is very broad. We attempt to break this massive subject into comprehensible parts and to build, piece by piece, a survey of the state of the art in communication systems and how it works. This introductory lecture begins by looking at trends in data communications, illustrating a general model of communications, and explaining the rapid growth of communication systems. This lecture is broken up into 2 units. In Unit 1, we first look at trends that are increasing the challenge for the business manager in planning and managing such facilities. Then, in Unit 2, we look specifically at the requirements for ever greater transmission speeds and network capacity. We will begin with Unit 1, where we look at current trends in data communications traffic and a communications model. The development of new services, advances in technology, and overall traffic growth are 3 leading forces that change the architecture of data communications. Over the years, communication traffic have kept growing at a high and steady rate. The traffic across our networks has grown to include more and more video, audio, and images aside from the traditional voice data. More businesses and individuals are using technologies such as web services, remote access, online transactions, and social networking, leading to more traffic usage. The demand of services such as mobile broadband through the use of smartphones and tablets are also leading to increasing network traffic. Growth in services and in traffic capacity go hand in hand. The figure shows the mix of traffic and the growth trend for cable internet subscribers. We can see from the figure that cable internet subscribers have increased their use of streaming media on average, causing the overall average data rate per subscriber to also increase. There are 4 notable trends in technology that we can observe. The first trend is that computers and devices, along with communication media, have been getting faster and cheaper. Second, today's networks are more intelligent with customizable services and differing levels of quality of service to ensure high-quality support of applications. Third, businesses and individuals have relied more and more on the internet, the web, and associated applications. Basically, everything is connected to the internet nowadays. Finally, the last trend is mobility, with consumer devices and a popularity of cloud computing. Although wireless communications are on the rise, wired data communication growth, such as Ethernet, also shows high demand and keeps increasing. In the figure, we see that the internet backbone data rate demand in a network core doubles approximately every 18 months, while demand in enterprise or in LAN applications doubles approximately every 24 months. Networking technologies must change to keep up with the high traffic demands. This includes high-speed local area networks, or LANs, in the business environment, business wide area networks, or WANs, and commercial electronics. We will take a look at each of these in turn. The emergence of high-speed LANs was caused by the role of personal computers. Because of the increase in speed and computing power of personal computers and management information systems organizations recognizing the LAN as a viable and essential computing platform, the volume of data to be handled over LANs had to increase. Centralized server farms, power workgroups, and a high-speed local backbone all required high-speed LANs for them to function. In the corporate world, The growth of telecommuting, increased reliance on servers and workstations, increased use of data-intensive applications, storing data on the cloud, and others all led to the creation of high-speed WANs. The ever-changing corporate data traffic patterns meant that high-speed WANs were now necessary to keep up with demand incurred by the corporations. The rapid conversion of consumer electronics to digital technology also has an impact on both the internet and corporate intranets. New gadgets are increasing the amount of images and video traffic carried by the networks. Examples of this conversion of consumer electronics to digital technology include DVDs replacing VHS tapes and CD-ROM drives in computers. Also, our smartphones and laptops can easily record video, which users can upload to a social media site or YouTube for others to view, just like how the welcome message for this class was recorded and uploaded. This all adds to the traffic burden of our networks. Convergence refers to the merger of previously distinct telephony and information technologies and markets. It involves moving voice into a data infrastructure, integrating all the voice and data networks inside a user organization into a single data network infrastructure, and then extending that into the wireless arena. The foundation of this convergence is packet-based transmission using the Internet Protocol, or IP. Applications convergence involves combining electronic subsystems that mix voice, data, and video into all sorts of electronic equipment. At the enterprise services level, the manager deals with the information network in terms of the services it provides to support applications. Infrastructure convergence involves carrying different types of traffic for which the network was not originally designed for. For example, our cell phone networks were designed for voice traffic, but we send video, images, text, and data through it. A simple communications model is represented by the figure. The purpose of a communication system is the exchange of data between two parties. The source is a device that generates the data to be transmitted. Your computer is an example of a source. A transmitter transforms and encodes the information in such a way as to produce electromagnetic signals that can be transmitted across some sort of transmission system, just like how a modem takes a digital bit stream from an attached device, such as a computer, and transforms that bit stream into an analog signal that can be handled by a telephone network. The transmission system is a network connecting source and destination. The receiver accepts the signal from the transmission system and converts it into a form that can be handled by the destination device, like how a modem accepts an analog signal coming from a network and converts it into a digital bit stream. Finally, the destination takes the incoming data from the receiver. In reality, a data communication system is actually not as simple as what we saw on the previous slide. It is a technically complex system that has to generate signals, be efficient, have a level of security, detect and correct errors, implement flow control, route traffic, perform addressing, recover from failures, synchronize between transmitter and receiver, and allow a device to interface with the transmission system. Therefore, we came from a simple model to a long list of data communications tasks that encompass all of the activities performed through data and computer communications.